Hello and welcome back to the next session of microbes in human welfare. Now you should be very serious about all the classes because we are covering more than 50% of the syllabus in the online classes. So that's why be very particular and be serious about the syllabus. Okay, now let's continue with the next part of the microbes in human welfare. In this part, after STP, sewage treatment plant, we are continuing with the biogas plant. Now, what is biogas? Biogas is a mixture of gases, predominantly consists of methane gas, and this is produced by the activity of microbes, especially the archaebacteria called as methanogens, and it includes certain bacteria also. That bacteria is nothing but methanobacteria. Now let's define biogas and let's see the alternative term for the biogas. So biogas, it is the mixture of gases that predominantly consist of methane gas, produced by the activity of microbes, especially anaerobic and which can be used as a fuel. So this is the definition for the biogas. So biogas, it is a mixture of gases that predominantly consist of methane gas. So majorly it consists of methane gas, and that methane gas is produced by the activity of microorganisms, and especially these microorganisms are anaerobic in nature. That means where it carries out its activity in absence of oxygen. Okay. Now this can be used as a fuel also. So what is this fuel? We'll see it in the next part. Now biogas is also called as a gobar gas. Now this biogas is also called as gobar gas. Then why biogas is called as a gobar gas? Because the raw material used is cow. The raw material where we use for the production of this biogas or methane gas is cow dung. Because of the use of raw material in the form of cow dung, biogas is also named as gobar gas. Now gobar, it is a term which is taken from Hindi. Okay, gobar refers to the dung of the cow dung. So that's why biogas is also said to be gobar gas because the raw material used is cow dung. Then apart from cow dung, what can be used as raw material? Even the vegetable waste, the fruit waste, it can be also used as the raw material for the production of the biogas. And this biogas is nothing but it is the methane gas. Now, as far as this biogas is concerned, we have an experimental setup for this because the biogas plants, they are mainly produced in rural areas. So how they are produced? We have a typical biogas plant, and let's study this with a diagrammatic representation. Now in a typical biogas plant, we have an inlet, we have an outlet, a major digester. So here we have a typical biogas plant where this is used in the rural areas. So this is an inlet. Now this is the major tank, the bigger tank. Now here we use one more tank where we call it as the stainless steel tank. On which a gas pipe is connected. Okay, so this is the top, or we also call it as the lid. Okay, now this is the digester. This side we have a rubber tube also. This is a rubber tube which is fitted. Okay. Now here we have an inlet. This is the digester, which is made up of concrete tanks. And here we have the gas. Mainly CH4 plus CO2 plus other gases. Here this is called as an inlet. Here it consists of dung and water. This is the digester. This is the gas holder. This is gas. This is a pipe where we connect, and this side we have the spent slurry. Okay, now this is a typical biogas plant. So we call it as a typical biogas plant. Now, what is done by using these biogas plants? Now already we know biogas is nowadays widely used. Okay, so first let's see its functioning and later on we will see its uses. Now there are majorly 1, 2 and 3 tanks which are constructed. The first tank is called as an inlet tank. Now in the inlet what we add? We take the cow dung, mix it with water, it forms into a fluidic matter where we call it as a slurry also, that is poured into the tank. This tank is called as an inlet tank. That's why this tank is also said to be an inlet tank. Okay, so here we call it as inlet tank. Then, after adding dung and water, it forms into fluidic matter. That fluidic matter enters into the larger tank, which is called as a digester. Now the digester, this is made up of a concrete tank, and this digester, so digester is made up of concrete tank and measures 10 to 15 feet depth. That means the depth of this tank is around 10 to 15 feet. Okay, so this is below the ground surface. Okay, suppose if we take this as the surface of the ground, below the ground surface, we are digging a pit of around 10 to 15 feet, and it is made up of a concrete tank. And even the biogas plant can be made up of stainless steel also. So this is a concrete tank where we call it as digester. It measures around 10 to 15 feet in its depth. Okay. Then dung and water, when they are allowed here, when they are allowed to settle, then there are microbes which are present in the cow dung. Those microbes are called as methanogens, and the bacteria which is present in this cow dung is a methanobacter. This methanobacter undergoes various processes called as solubilization, which is also called as hydrolysis, second acidification, and third one is methanogenesis. By all the three processes, what are these three processes? Let's see that part. By all the three processes, methane gas is produced in the digester. Okay. Now after adding dung and water, immediately whether the methane gas is produced? No. Now after adding cow dung and water, we have to leave it for minimum around 45 days to 2 months in the initial case. After leaving it for about 45 days, say about more than a month, then the microorganisms undergo anaerobic process. By anaerobic breakdown of these complex organic matter, methane gas is produced. The methane gas which is produced in this digester goes on accumulating at the top. This top, it consists of a floating chamber. This is also called as a gas holder. Now this is we call it as a floating chamber because it is made up of stainless steel, and it is fitted with a rubber on its side so that the gas should not leak out. Now the biogas, where we also call it as methane gas, it goes and accumulates in this gas holder. As the gas is produced, the gas holder, it moves at the top. If the gas is used, it comes down, so that we can understand whether the gas is produced or whether the gas is used. So the methane gas is accumulated here. When the methane gas is accumulated here, as it puts the pressure, it moves upwards and the gas enters into the gas pipe. Now this gas pipe can be connected into the kitchens. It can be used for cooking purpose. It can be used for lighting purpose also. Okay, so this is how the biogas is used. The major gases that are produced in the biogas plant are, so the gases produced in biogas plant are methane, carbon dioxide and hydrogen. These are the most important gases which are produced in the biogas plant. Because in the previous part, in the sewage treatment plant also, we came across the biogas which is produced in the anaerobic sludge digester. Now this is also called as an anaerobic sludge digester because anaerobic microorganisms like methanogens act on the organic matter and they will produce the gas which is called as a biogas. But there is a difference in terms of the gases which are produced in STPs in the biogas plant where we are using the raw material as a cow dung. Now look at this. The gases which are produced here are, first one is methane, second one is carbon dioxide. Both are common. Look at this. Here hydrogen is produced. The third one is hydrogen. Remember, in the biogas that is produced through STPs, there H2S hydrogen sulfide is produced. Okay, so there also we came across three gases. We are coming across these three gases according to your NCERT because apart from this, even other gases are also produced. Now, according to your NCERT, CH4CO2 is common. H2S is produced in STPs, sewage treatment plant. H2 is produced in biogas plant. So remember the difference because the gases will be asked for an objective part also. Okay, so this is regarding the part of the gases which are produced in the biogas plant. Okay, the gas can be used later on. The used slurry of the cow dung. After the inlet, after the production of the biogas, the spent, we call it as a spent slurry also. The spent slurry enters into outlet. This tank is also called as outlet. This is an outlet tank. It comes and accumulates. And from this outlet tank, this can be taken and it can be removed. After taking this spent slurry, this is not a waste material. Again, it can be reused. It acts like a manure which can be used in the agricultural field. Look at the dual benefit of a biogas. One benefit is we produce the methane gas. Second one is even the fertilizer is also produced. Okay, that can be used for the agricultural fields. Okay. Regarding the STP, we are comparing these two. In the sewage treatment plant, there is again dual benefit. In the biogas, again there is dual benefit. Then what is the dual benefit of STP? First benefit is we are reducing water pollution. Second benefit is we are producing biogas in sewage plants. In this biogas, first one we are producing biogas, second one manure is produced. Look at this, because it is a cow dung which can be used as manure. Okay, either it is a vegetable waste. After the act of the microorganisms, it forms into manure. That manure can be used into the agricultural field. This is the dual benefit of a biogas plant. Okay. Now, this is regarding the part of the NCERT. Let's see some additional part of this. How exactly the biogas is produced by the action of microbes. Okay, so let's plot here and see. Now the raw material where we add in the inlet, it consists of a dung. What does the dung consist of? The cow dung consists of majority of the organic material. Those organic material may be certain proteins, fatty substance will be there, even carbon substance will be there. Along with that, cellulose will be there, hemicellulose will be there. Okay. Now here what we take is fat, proteins, cellulose, hemicellulose. These are the organic substances which are present and they are converted into soluble compounds. Or call them as monomers. Okay, with the help of a decomposer microbes. Here we come across the decomposer microbes. Okay, now this is called as stage 1. We call it as stage 1. Where we call it as hydrolysis. This is called as hydrolysis. Then these soluble compounds, they are converted into organic acids. It is converted into organic acids with the help of a fermentative microbes. And this is called as stage 2, where we call it as acidogenesis. Then these organic acids are converted into biogas that consists of CH4 and CO2 majorly. And this is by the action of methanogenic bacteria. Methanogenic bacteria, where we call it as stage 3. Methanogenesis. Now look at the steps. The first step is said to be hydrolysis. The second step is said to be acidogenesis. The third step is said to be methanogenesis. By the process of hydrolysis, acidogenesis and methanogenesis, in the digester, methane gas is produced. What does the raw material consist of? The raw material consists of fats, proteins, cellulose, hemicellulose. By hydrolysis process, by hydrolysis of all these, with the help of a decomposer microbes, they are converted into soluble compounds, where we call them as monomers, because these are polymers. Polymers are converted into, they are broken down into monomers with the help of decomposer microbes. These soluble compounds or monomers, they are converted into organic acids, and the process is said to be acidogenesis, because acids are produced, organic acids are produced, hence the step is said to be acidogenesis. This is the second step. And this process occurs with the help of fermentative microbes, where the microbes undergoes the process of fermentation. Organic acids are converted into biogas, mainly CH4, CO2 and H2 in case of the biogas plant. This process is called as methanogenesis. Production of methane gas is methanogenesis. So hydrolysis, first step, acidogenesis, second step, and methanogenesis, third step. With these three steps, biogas is produced. All the three steps occurs in the digester. The biogas is produced. This biogas is useful and it is commercially used. This is how the biogas is produced. This is an additional content apart from your NCERT, because this is not given in your NCERT. Okay, now the question comes. Here in the biogas plant, the raw material we use is cow dung. The cow dung consists of cellulose. Now, the cow dung consists of a bacteria called as a methanobacteria, where we call it as a methanogens also. With the help of methanogens, we are producing biogas. But the same bacteria are also present in the rumen of cattle. Rumen is a part of a stomach or the gut region in the cattle. What is the use of methanogens in the rumen of cattle? That means, does it produce biogas in its gut region? No. Here we have a most important function. Okay, so let's go to the function. The methanogens are present in the rumen of cattle. That helps in digestion of cellulose. It helps in digestion of cellulose. Remember the function of methanogens. Methanogens, especially it is methanobacteria. We call it as a methanobacter. The function of the methanobacter, where we call it as methanogens, as it is present in the rumen. Rumen refers to the gut region, part of the stomach of a cattle. Methanogen bacteria are present in the rumen of the cattle. What is its function? Its function is digestion of cellulose. It is an objective part. Remember it most carefully. Okay, it's a common question. The role of methanogens in the rumen of cattle is a digestion of cellulose. Okay, now we cannot digest cellulose. Suppose if the animals eat paper consists of cellulose, it is easily digested in the cattle rumen, but it is not digested because we don't have cellulase enzyme which helps in digestion of the cellulose. Okay, so this is the function of methanogens in the rumen of cattle. Okay, now regarding the part of the biogas, let us look at the part where it was initiated. Now, these biogas plants, we don't find them in the cities, we find them in the rural areas. Okay, now we don't find the these biogas plants in the cities. Why? Because of the non-availability of the raw material. The raw material which is used here is cow dung, so that's why this is used in the rural areas. The biogas plant was initiated by mainly two commissions. What are those? Bills. The biogas plant was initiated. Remember, we use the term biogas plant. Plant is a constructed building. Plant do not means that it is actually a true plant. Okay, so there is no biogas plant here. We call the construction building as a plant. STP, sewage treatment plant. Plant means it is a constructed building. It is not actually a true plant. Okay, don't confuse with that part. The biogas plant means the constructed biogas plant was initiated by Indian Agricultural Research Institute, where we call it as an IARI, Indian Agricultural Research Institute, and Khadi and Village Industries Commission. Where we call it as a KVIC. Look at this. The biogas plant was initiated by IARI and KVIC. Remember, these two are important here. It was initiated. The Indian Agricultural Research Institute (IARI) and KVIC. So these two have initiated the biogas plant in the rural areas. They are supporting the biogas plant. Then why we have to support the biogas? Because instead of using LPG, liquid petroleum gas, biogas can be best used because it is cost free. Because we have to pay for the LPG, but for the biogas plant, if you have raw material, that's enough. No need to pay for it. And here it is having dual benefit. Okay, what is the use of the biogas plant? First, what we get? We get biogas or methane gas as a fuel. So what is the use? So if we look at the uses of the biogas plant, it can be used for cooking purpose. Then apart from the cooking purpose, now this can be used for lighting purposes to glow the bulbs. Then it is also used to start the motors in irrigation fields. Now we call them as water pump sets. Okay, that means even for the water pump sets also the energy can be used for the purpose of irrigation. So this is regarding the useful part. And one more thing is it is more efficient. It do not produce any pollution. Okay, this is the best part of the biogas. Okay, so this is regarding how exactly a typical biogas plant works. Now there are different models for the biogas. This is a typical biogas plant. Apart from this, there are other kinds of biogas plants also. So here we came across a typical biogas plant, and we'll go with the explanation of only this plant because nowadays many models of biogas plant are available. The biogas plant can be used above the ground surface also, it can be used below the ground surface also. If it is used above the ground surface, we are using stainless steel, bigger tanks of around 1000 liters together, and underground tank, it can be used for even larger purpose also, even for the smaller purpose. That means large scale and small scale, both are there. It depends on the availability of the raw material. If raw material available is in large quantity, we can produce it in more quantity. But what is the negativity of the biogas? The negativity is it can be used only in the rural areas. Now the biogas which is produced here, this can be used by only one family. One family, a set of members consisting of 5 members or 6 members, because in the village, if you go to the home, minimum of 5 to 6 members will be there, even more than that will be there. So for one family, the biogas can be used, and it cannot be commercially exploited. That means if you think that we can produce a lot of biogas, fill it into a tank, then sell it, market it, no, it is not possible, because this is not produced in such a large quantity. That's why it can be used by a single family. Okay, so this is regarding the part of a typical biogas plant, and in the next class we'll continue the next one. Thank you.